Hey gang, today we're going to be proving that triangles are similar. And that's what's called a proof. You'll be doing a lot of proofs when you get to geometry at the high school level. So two triangles are said to be similar if they have two pairs of corresponding angles that are equal. So like we did with transformations, when we knew shapes were similar if only a dilation occurred. That dilation occurred, it made the shape bigger or smaller, but the size of the angles do not change at all because the shape stays in proportional relationship to the larger shape or smaller shape. So determine whether the pairs of triangles given are similar or not and explain. So we know that the measures of of a triangle should all add up to 180 degrees. So if we take a look at these two, we want to see if the three angles or the three corresponding angles are exactly the same. And here we see A is 31 and over here A is also 31. Here we see B is 103 and here we see B is also 103. So that means C has to be the same. We could do the work. If we do 103 plus 31, we get 134, and then 180 minus 134 is 46. So both C and C prime are 46 degrees. So here we can say these triangles are similar because all of the corresponding angles are congruent. And that's going to be our catchphrase here. Whenever we have similar triangles, and we know they're similar because of the angles we're going to write, the triangles are similar because all of the corresponding angles are congruent. The triangles are similar because all of the corresponding angles are congruent. Try to get that in your head. You want to memorize it. That's how you know that two triangles are similar and can prove that they're similar. Let's take a look at another one. So number two, again, we want to do the same thing. Here we have A prime and A are both 31. Those are the same. But then we have B prime and B prime being 103 and B being 85. Those are not the same. So right away, we should know that these are not going to be similar triangles. But I want to go a step further and prove it. So here, like we did before, that 103 and 31 makes 134. Then we subtract 180 minus 134. And we get 46. So this is going to be 46 degrees. But over here, if we do 85 and 31, we get 116. And then we do 180 minus 116, we get 64 degrees. So here, these triangles are not similar because not all of the corresponding angles are congruent. Okay, so I hope that's making sense to you. Again, what makes two triangles similar is having all three corresponding angles congruent to each other. All right, let's keep going. Number three. So again, we want to look for the corresponding angles. We see A is 72 here, and A prime is also 72. And then we have C is 48, but we don't know the C prime. And B prime we know is 60, but we don't know B. So we got to go ahead and figure out those angles before we can make any conclusions here. So I'm going to start by adding 48 and 72. 8 and 2 makes 10, carry the 1. 7 and 5 makes 12, so that's 120. Then 180 minus 120 is 60. So B should be 60, which is equivalent to the 60 degrees we have for B prime. But let's make sure that our math works out for the larger triangle. So we do 72 plus 60, and we get 132. And then we do 180 minus 132, and we get 10 minus 2 is 8, and 7 minus 3 is 4, which is 48. So it is congruent to C. So we've proven that those two triangles are similar. Once again, because all of the corresponding angles are congruent. Okay, so memorize that sentence. They either are or they aren't. They are if all the sides are, all the angles are congruent. They aren't if not all the angles are congruent. All right. So you're going to try 4 through 6, not 3 through 6, 4 through 6 on your own. And for number 5, label A prime 95 degrees. Obviously, that was left out. So make sure you put that in so you can actually make sense of the problem. Okay, moving on. Number 7. All right, so number 7, if we have similar triangles, that means their side lengths are proportional to one another. And we can use proportions to find missing lengths. So we have, is triangle ABC similar? That symbol right there means similar to triangle A prime, B prime, C prime, and explain. So we look at the angles. We see B is 92, and so is B prime. We see A is 59, and so is A prime. Now, if those two are the same, obviously the third is also going to be the same. So we can say, yes, they are similar because all the corresponding angles are congruent. Okay, so now determine the length of A prime C prime. So now we're going to start setting up some proportions. This is going back to some 7th grade math work. So A prime C prime is A prime to C prime right here. And that is not given a side measure. All right. That side should be proportional to this side. And then we have to figure out another side that we can work with that we have both measures. So if we see here AB and AB prime is given, so we can work with those. So I'm going to do AB over AB prime equals AC over AC prime, going from the smaller triangle to the bigger triangle. It always helps to set that up to make sure that you are being proportional here and not messing up the ratio. So we have AB is that 3.2 over AB prime is 512 equals AC, which is 6.1 over x, because we don't know that measurement. So now we're going to cross multiply. Remember back to last year, whenever you have a proportion, you cross multiply to find x. So x gets multiplied by 3.2. So I have 3.2x. And then 5.12 gets multiplied by 6.1. So we can use our calculator here if we're not 100% sure of that math. And again, the goal here is just to do it pretty quickly, so we don't want to struggle with that. So 512 times 6.1 gives us 31.232. And then we're going to divide by 3.2, divide by 3.2, and we get x equals 9.76. So I'm going to go over here and label that this side, the missing side, is 9.76 units. They don't give us a unit measurement, so I'm just going to leave it as 9.76. All right, then underneath that it says determine the length of BC. So BC is this side here. And again, a length is not given. So we have BC prime or CB prime right here. So we can use that to help us find this missing side. And we can use the ABs that we used before. So we can do AB over AB prime like we did before. And then that's equal to BC over BC prime. Okay, again, going from the smaller to the larger. All right, so AB again is that, sorry, what did I have here? AB is 3.2 over 512. equals. Now we're looking at the BCs. I don't know my BC, but I do know my BC prime is 8.96. It's throwing me off that they put CB there. It should be BC. That makes more sense. All right, so now I want to cross multiply again. So x gets multiplied by 512, making it 5.12x equals 8.96 times 3.2, which is 28.672. And then we're going to divide by 512, giving us an answer of 5.6. So this missing side over here is 5.6 units. Now, all of those should be in proportion to each other. One way we could check that, what we could do is figure out what we multiplied 3.2 by to get AB prime. So if we do 512 divided by 3.2, it's 1.6. So it looks like we're multiplying by 1.6, but we can check all the others. If we do AC, which is 6.1, and multiply it by 1.6, we should get 9.76. So if we do 6.1 times 1.6, sure enough, we got that 9.76. And checking it one more time, we have 5.6 times 1.6 should be that 8.96. And sure enough, it is. So our scale factor is 1.6, which if we had figured that out first, we could have used that idea to also help us find the missing sides. So here, instead of doing the proportion, I could have just done 6.1 times 1.6, and I would have gotten the 9.76. And here, I could have done 8.96 divided by 1.6, and I would have gotten the 5.6. So if your brain works that way and you can figure that out more easily, go for it. Or set up a proportion, whatever you like best. All right. Okay, moving on. Come on. Come on. So you guys are on your own for the rest of the lesson. Complete your exit tickets. Make sure you finish the missing problems that were not in the video, and then you can start tonight's homework.